Hello, hello, hello. So we are back and we were doing a chapter on module 9, which is functions. So we'll continue from here and we should take it from while let. All right. So that is a continuity between. So this was while let and we'll revise it once I get at my stream is live. Yeah. So let's start. So while let. So similar to if let, while let can make awkward match sequencing or sequences more tolerable. Consider the following sequence that increments I. Now make a option of type, option I32, which is something like this. Sum has a value 0, and repeatedly try this test. So there's a test which is loop inside match, and then there is a sum I. So we are matching optional. So if there is some I in the optional, and if it is greater than 9, then we print it's greater than 9, and we assign the value of optional as none. Else, what we'll do is to say that I is this and try again, and we'll append 1 to the value of sum in optional. So that's what we do, and it requires three indentation. Means it is very much nested, sort of nested. One into another, another into something else, something else into if else. Well, it is very nested, and sometimes it can be confusing and very not considered a very ideal sort of situation. If you find yourself forming some nested loops or nested anything in a programming language, it's not considered that it's up to par. You should think of something alternative to that, because we have alternatives. So we are using while let to do the same thing, but with a better syntax and with a better clarity also. So we make the optional again with sum of value 0, and if we say this time that while let, we have read about if let, we have, and we now have while let. See, if let, and there was also let else. Yeah, I remember that. Now this is while let. So while let was that if there is some I, which is now we are optional, this is optional. So we are sort of destructuring it into let some I, and then we are comparing this I. If it is greater than 9, then we print that greater than 9 and quit, and we make the optional, we assign the value of none to the optional. So it's not sum 0, it becomes none if it is greater than 9. But since we are starting from 0, it's not always greater than 9. So we have to append 1 to the value of sum, so that it can become something like plus 1 and can go beyond 9. And as soon as it gets there, we make optional as none and we return from it. So let's see, both of them will give us the same result. And here, yeah, we have to break this also, because this is a loop. All right. So if nothing matches, we are breaking it inside match. If some I has value, then do this. If nothing, then break it. So that optional, as soon as it becomes none, we break out of the match, which is inside a loop. Right. So it gives us that I 0, 1, 2, 3, 4, 7, 8, 9. After 9, it says, yeah, it's greater than 9. So we are quitting. For while let also, it will say the same thing. So we are getting the same result with sort of a different syntactical usage. So this seems much better, because there is a much more understanding over here. But the earlier one is loop inside that match, inside that, we are matching something. Inside that we have if else condition. So it is very nested and bad for understanding, because you have to use your mouse pointers and see what's happening. If you even miss out a single detail, you'll do something stupid. So yeah, that's what we studied yesterday. Now we'll today start from functions. So functions are what? Functions, we have used function as main. We have made our own functions. So now we have came to this module of functions. So functions are declared using fn keyword. We know that because here we have written fn main and many other functions, rectangles, squares, and all that. Its arguments are type annotated just like variables, and the function returns a value. Yeah, using these arrows, and then it tells you what is the return value, isn't it? Over here, it's Boolean, like is divisible by is a function which will return a Boolean, and fizzbuzz is also a function which takes n as u32 and also returns not Boolean, but this time it is a unit type. All right, means a default. So even if you don't mention this, it will get returned by default. That's what happens. But if you mention it, it's good. It like you can see it what it is returning, and you can infer from it. You don't have to see this whole damn code of this function so that you can get to know what it is returning. So it is considered a very good practice. But this since this is a default return value, so you probably don't have to explicitly return it. It gets implicitly returned. So let's see what else. So if function returns a value, the return type must be specified after an arrow. That's what we learned. After an arrow. So the final expression in function will be used as return value. Alternatively, the return statement can be used to return a value earlier from within the function, even from inside the loops or if statements. So the final expression of function will be used as return expression. What is that? If see this has semicolon, so it is a statement now. Since this has no semicolon, this value has no semicolon. Now this is not a statement just. This is now an expression. All right. So if there is no semicolon at the end, we we say it's an expression, and the last expression that you have in a function gets returned automatically. So that's what it's telling me, that final expression or the last expression in the function will be used as return value, uh, and alternatively the return statement can be used, like if I make this expression as statement, so I can explicitly use return, and it will do the same damn thing, so nothing to worry about. All right. So alternatively, the return statements can be used to return a value earlier from within the function, even from inside loop or if statements. Yeah, we know that. So if there is a if statement and we are using semicolon, so probably not return anything. But if we don't, then it will return it. We have seen it. All right. So let's rewrite this fizzbuzz using functions. All right. So unlike C or C++, there's no restriction on order of function definition. So I don't know what that means, like restriction on order of function definitions. Oh, so yeah. So before in C there is something like if you describe some function below main, so you have to sort of prototype that function above main. So sort of the first thing or first line of that function has to be there at the top of the C or C++ code. I think that's what it is trying to say. Otherwise, you just have to keep your main down below somewhere here. But it is trying to say me that there is no restriction on the order of function definition. So you can define functions anywhere. There's no specific order that you have to define first this function, then this function at the last main. There's no such thing in Rust. We have known that for quite a lot of time. So we first of all define main and use a function that is fizzbuzz, and two, we are inputting 100, which is u32. All right. How did we know that? Because this function takes u32. So if it is anything else, we will just try converting it, and if not, then it will throw an error. So we can also specify that using sort of u32 directly, or just to keep it separate, you can use underscore, because it doesn't matter. All right. It gets sort of automatically removed or something like that. That's what happens. So unlike C or C++, there's no restriction on the order of function definition. We know that. In main, we are passing fizzbuzz2, and we are passing a number which is 100, which is of type u32, and we can use this function here and define it somewhere later. Yeah, like this. We are defining it somewhere really later. All right. So this function fizzbuzz2 is over here. So when the function returns something like void type, over here it's not returning anything, so it is implicitly returning a void type. Sorry, not void type, it's unit type. All right, sorry. So the return type can be omitted from the signature. Yeah, since that's what I said over here. So it is also returning a unit type. The annotated result can or the signature can be removed from here. It will not impact this function anyhow. What else? So there's a function that returns a boolean value, boolean as a value. So if we say like let's say LHS, which is left hand side, and RHS, which is right hand side, they both are a number which is of type U32, and we are saying that the return value of this function, which is divisible by, will be a boolean, which is true or false. So we say if RHS equals to 0, then return false. Now this is an expression. The return keyword is not necessary here. Yeah, it is not necessary because it was not like this. It was earlier like this. So obviously return was not necessary over here. So because this was an expression, all right. But the corner case where we have to return early, we can do this. Where we can just define that we have to return from here and use a semicolon, exactly like we used to do. I can't, if you can't digest it somehow, you can use return like normally. Like there's no, restriction over that. But it's better. It looks nice. We know that this is a return value since there is no semicolon and it is not causing any sort of error. All right. So now this is an expression that returns the keyword is not necessary over here. Now there is a function that don't return a value actually returns the unit type. All right, so this is a fizzbuzz function which takes the U32, which is n, and returns well, nothing, or a unit type, which is default. So there is a if divisible by inside this function is running if divisible by, then it's saying n is n and comma 15. So we print fizzbuzz. We are passing n and 15. So if this n, or whatever the number we are sending to fizzbuzz, if it is divisible by 15, it means it is divisible by both 3 and 5 because 15 is the LCM of them. Now else if it is divisible by or is divisible by n3, so both n and 3 will go LHS and RHS, and we see that if it's divisible or not. But if it is divisible by 3, then we'll say it is fizz. If it is divisible by 5, we'll say buzz. Else we'll say this is the number. We'll just print that number. So function that don't return a value actually returns the unit type. So all right, so we have this function, and inside the fizzbuzz2, like we are just calling this function inside another function, inside a sort of loop. So for n in range of I to equals to n. So not only we are going one step below n, we are going till n, which is equals to n. If n is 100, we'll go not only till 99, we'll go till 100, which will be in element terms, which it will be sort of you know 101 elements if we were not to mention this one. But since we have mentioned that this range is starting from 1 and it's going till 100, so there are only 100 elements. But if we have not mentioned it like we usually do, or we usually don't, then it would have taken from 0 automatically to whatever 100 or 101 elements. So we'll use 1. Now it looks good. This should work fine, and this will give us the fizzbuzz. 1, 2 is just a number, so we are just printing them like normally. And 3 is divisible by 3, so we are saying fizz. 5 is divisible by 5, we are saying buzz, and so on. 6 is by 3, and this is fizzbuzz. So 15 is divisible by both 3 and 5, so we are saying fizzbuzz, right? So we have seen this function, we have used it, we have worked with it. Let's move on. Now, associated function and methods. So what are these? So some functions are connected to a particular type. Like these come in two forms: associated functions and methods. So associated functions are functions that are defined on a type generally, while methods are associated function that are called on a particular instances of type. So we are seeing that we have a struct point, and we are implicating or implementation of point for what? I don't know, for anything. Is that if function origin, which is sort of a method, is point, then we'll go like x is 0, 0, y is 0, 0. Another new point, we'll input that new point. It is initializing, so it has the origin of 0, 0. Origin is always 0, 0. And if we want that point to move from origin to somewhere, we'll put the coordinates and it will be returned over there. So we have a new method. We are doing the rectangle, the same thing. So we have a first of all area, and then we have a perimeter method, and then we have a translate method also. Then these all functions we have seen somewhere. We have used it. These are not only functions; these are structures which are sort of a type. Like U32 is a type, I32 is a type, and a float 32 is a type, F32, and Boolean is a type, character is a type, string and ampersand string are a type. So we are defining our own type, which is pairs, rectangles, and all that. Inside those types, we are implementing them on methods. We've also seen lists, and these are some of the longest codes. Not some of them, but yeah. So let's start from first point. So we have a struct which is named as point. It has two values x and y. Both are of type F64, which means float 64. Now the implementation block, which is all points associated function and methods go in there. All right. So all points associated function or methods go inside this implementation. So we said, function and methods. I don't know which one is which. So like origin is method or function, or new is a method or a function. Well, it looks like function, but that's how methods are also defined. So, but methods also sort of take the self, no? Yeah, so that's what a sort of a difference is. If sort of a function is defined, but it also takes the self, which means ampersand self, then I guess that is a defined method. But if it doesn't take self, then it is just a function. All right. So now this is an associated function because this function is associated with particular type, that is the point, point. And associated function don't need to be called with an instance. These functions are generally used like constructors. All right. These functions are generally used as constructors. So associated functions like origin and new don't need to be called with an instance. Now, what is an instance? I remember seeing something like that, but what is an instance? Another associated function taking two arguments. So these are two arguments which are x and y, which takes the value of f64 or are of type f64 inside point. And as soon as they get the value of f64, they return a type which is of type point. So that's another associated function for points. Now we are creating a struct which is rectangle. It takes p1 and p2, both are of type points. Now they are not coordinates like these. Inside these points we have x and y for both of them. For 1 and 2, both of them we have x1, x2, y and y1, y2. Sort of, no, x1, y1, x2, y2, sort of like that, right? Now we are implementing rectangle or implementation for rectangle. Now this is a method. Area is a method. Perimeter is a method. Translate is a method because it takes the cell, right? So now this is a method. Ampersand self is a sugar for self is a sort of type ampersand self, where self is the type of the caller object. In this case, self is the rectangle. If there was self over here, then in that case it would have been a point, and if there is another, so if this would have a self, then it would have been of type sort of pair. All right. So where self is the type of the caller object, in this case self is rectangle. Now there is a function, not a function now, it is a method. So this is a method. So area, which is a method which takes the self and returns a value which is f64. So what does this area do? It takes the first point, which is x1, x1, y1, and it takes that point from self.p1. So whatever, we are passing the rectangle, it takes that rectangle from self, and using that self, we are calling that point p1 that was defined here as p1. So we are calling that point, and we are destructuring that point in this sort of format. We are destructuring the self.p1 point that was defined from here, and we'll assign it some value in main. All right. So let's move on. Now this is x2 and y2. We are taking that from p2, which is point 2 in rectangle. We are taking that from self. Remember that we are passing on self, which is of type rectangle. It has, since it is a type of rectangle, it already has p1 and p2 defined. That's why it is of type rectangle. It's funny, but somehow we are going deep into this function. All right. So now we are calling just self using self.p1 to destructure point 1. We are using self.p2, destructuring it like this. Now ABS is a F64 method that returns absolute value of the column. So then what we are doing is x1 minus x2 multiplied by y1 minus y2, which means length multiplied with breadth, and we are returning an absolute value because we are not using a semicolon over here. If we would have used semicolon, then we have to say explicitly that return this value from this method area. So if we call area on any sort of a rectangle predetermined or predefined, then we can obviously get a return value which is absolute, but it is a area. So area in absolute. What is ABS? ABS is sort of a F64 method that returns the absolute value of the column. So whatever the absolute value is, it returns that. Now we have a parameter. Perimeter. What is parameter? Perimeter. Perimeter is, how much the fencing should take inside a rectangle or in a rectangle. If you were to fence that rectangular field, how much the fencing would be required. So that's perimeter. Now we are passing self, and we are this method is also returning a type F64, which is float 64, and we are returning an absolute type again, absolute value of this of the caller again. We are doing the same thing. We are sort of now calling the self p1, which is a rectangle defined, so it has p1. We are destructuring it. We are doing the same with p2. We have a rectangle, so it has point p2, and we are destructuring it. Now we get x1 y1 and x2 y2. What we are doing is we are taking x1 minus x2 and plus sort of y1 minus y2. We are taking both absolute values, we are multiplying them with 2. All right. It's like length plus breadth, but multiplied by 2. So it's good. And we are using brackets also, like we normally do in maths. Right. So we are first calculating that, then we are multiplying it with 2. That is what the perimeter formula is for rectangle. Now we have a translate method. I don't know what this does, but I'm getting an idea that it takes x, it takes again 0.2x. So this is x1, we'll call it x1 because it is taking that x from 0.1. So sort of x1, x2, then we have a y1, y2, and what we are doing is, well, we have a mutate reference of mutating self. So we can edit these values of x and y. That's what it's there for. So this method requires the caller object to be mutable. Now ampersand mute self t sugars to self is equals to ampersand mute self. And what it does, it can update the value of x and y. But it should have two values, no? But it's taking x and y only, and it's returning that same thing to sort of both the x's and both the y's. So it will make that just sort of lines. It will not be a rectangle anymore. It will be just a line. So this is our translate method, which updates sort of x and y both. But for that to happen, we must have a rectangle which is in a mutable variable. Otherwise, it will not mutate, because rectangle is just a structure over here. But in main, we should have a rectangle defined. See, it is an immutable rectangle defined here. So we can't just run this translate on this immutable rectangle, but to run that, we have to use a C, this mutable rectangle. So we have a mutable rectangle named as square, and we can run sort of a translate on that. Square translate and 1, 1. We are making that rectangle a square now. All right. So yeah, the rectangle was done. The translate method was done. Now we have a different structure, which is third structure in this function or in this code. Sort of, we have a structure pair. It takes box I32, which means it is storing a pointer. Again, box I32, again a pointer. So pairs owns resources to heap allocated integers. We can also write it like some sort of nice structuring, like we can press enter and enter so that it becomes sort of readable, human readable. But the earlier was also good, it was fine. Yes, it's only short, so it's storing a pair of what, we don't know it for yet, but these both are sort of pointers of I32, or sort of boxes of I32. They are integers, but they are heap allocated integers. So that's important. So pair owns the resources, like two heap allocated integers of type I32, not U32. Now we are implementing for pairs that it can have a method which is destroy, and that's it. So this method consumes the resources of caller object and self desugar to self, which is self, we know that. And if there is a ampersand mute self, then it will be a desugar of ampersand mute self. And if it is just ampersand self, it will be a sugar for just the self, or ampersand self over here. So this is important. Self is ampersand self is a sugar for self type, which is a reference of self. And second was ampersand mute self over here. Ampersand mute self is a desugar for ampersand mute self. And over here, if it is just self without any reference, we are just taking self as self. We are not taking that reference, we are moving that self from wherever it was now to a pair which will destroy that self. So what it will do is, we are saying, well, destructuring that self to first and second. Let pair be first and second, and we are taking that self, and we are saying destroying those pairs which is first and second, because that's what we did. We moved that sort of first or second or whatever it was to now this, because it didn't take the reference of that self, it directly moved that self to itself, if that makes sense. We have used self word like multiple times, but that's what it does. It is not taking a reference, which means it is not taking a ampersand self, it is directly taking the self. And for that to happen, we are moving the whole sort of pointer to now this new method. For just simple example, if there was let s1, let it be a value of string. I know I'm right outside main, but it's just an example. So if we have a sort of string which has a value high, and we go over s2, saying that let s2 be assigned the value of s1, what happens to s1? What happens to S1? We know that S1 is now moved to S2, because we were not taking the reference of S1, we were directly taking the S1, and we are assigning that to S2. Now S1 is becoming invalid over here. So it becomes invalid over here or below that. So that's what we are doing. We are not passing the reference of S1 or anything. We are directly passing the S1. What it does, it destroys or makes the S1 invalid. So That's why we are not doing anything, but everything happens because we are not taking a reference of self. We are directly taking the self. So it's a nice thing to, well, not to happen, but all right, we'll take that. Now there is a main, and we are using all these structures and methods inside these main. So yeah, it's not a very long main. So it looks long because there are multiple comments explaining what it does and what's happening. So now main has a, we are creating a rectangle. First of all, the point one is origin, and point two is point two has a coordinate of 3 comma 4. Interesting. It's rather interesting. So we are now printing that rectangle parameter is, then we are using rectangle and perimeter, which was a function. All right, which was a function. No, not a function. It was a method because it is using cell. Yeah, sorry. Function was origin and new for points. Yeah, I remember that. So point, and we are using origin, which is a function, not a method. This is a function, and this is a new, which is again a function inside a type called point. These are implementations that we have written by our own hands. And now there is a rectangle perimeter, which is a method inside a rectangle, and it gives you in return the absolute value of your perimeter. Same for the area, it is again a method, and we are printing it. Nothing wrong with this. Let's read this comment. So methods are called using the dot operator. Yeah, using dot, whereas associated functions are called using double colons. We have mostly used double colons most of the times. So we know how to use double colons. But we also know that now the method is, called using a single dot, which is full stop sort of. So methods are called using a dot operator. Note that the first argument, which is self, is implicitly passed. Like rectangle dot parameter is automatically equals to this, which is rectangle, which is a type, and we are passing the parameter, and we are passing the reference of the rectangle, because we are passing reference of rectangle, which is reference of cell, not directly passing the cell because it will move then. All right. So we know this is what's happening at the backside, and we are just syntactically sugarcoating it to something very similar looking or simple looking for us. And we should keep in mind that this is what actually is happening. We have a rectangle, inside that we have a perimeter, which is a method which takes the reference of a rectangle by self, right? Then we do something with this. We create parameter, we calculate the area, we print them. Now there's another mutable rectangle type, but we have named it square, so don't be confused. This variable is just a name. It is of type rectangle only. Now what we are doing is we are assigning it a point one, which is origin, which is 0, 0, and point origin is a function in a type point, and origin is the function inside that. We have implemented it at the top. Now we are assigning it a new value, which is 1, 1. And then what we are trying to do is we are saying square dot translate. Translate does what? Translate takes the, all right. So it makes the both x and y the same value. So that's what it does. So we have a comment which says error, rectangle is immutable. No, it is mutable. Oh, this rectangle, yeah, it is immutable. We obviously know that. But this method requires a mutable object. So rectangle dot translate 1, 1. Where is rectangle dot translate? It is square dot translate. Oh, over here it is telling us to sort of uncomment this line and see the error which will happen. What will happen is, since rectangle is sort of immutable, we can't just use this translate and use a self mute on it and try to change the value of x and y. We can do that on translate of rectangle. But as soon as we do this, we add this mute over here, mut. Now there is nothing wrong with our code. Now this will work. All right, so we shall see that square dot translate does it automatically because it is a mutable square. So okay, mutable object call can call mutable methods. We know that. And let pair is equals to pair, and box is new one and box is new two. So there's a pair. We are defining a pair. Then we are calling that pair to destroy. We are calling a method and to destroy that pair. So error is that previous destroy call consumed the pair. So you cannot do this again. How did it consume the error, the pair? We know that it transferred its ownership to itself. It transferred this pair's ownership to itself, and then it got destroyed automatically. All right, so let's run it. We shall see something happening. So no errors. Why? Because we have made this rectangle mutable. So we expected that. But now it is immutable and we'll try to do that same thing. But let's see. So rectangle parameter is 14, rectangle area is 12, and we are printing that, yeah, destroying pair 1 and 2, which we defined over here. All right. But now we have made this rectangle which is immutable again, back to immutability. And now if we try to run it, we'll get into some errors and we want to see that. So it says cannot borrow rectangle as mutable as it is not declared as mutable. That's what we expected it. See, so it is telling me to add this mutable or just don't use it. So if we do this, we are back to good again. All right, we are back. And now it's telling me to, try using pair destroy after just destroying that pair. So we cannot destroy it again. It's telling me to use this so that we can see some errors. So it tells us that use of moved value, which is pair. So pair was moved because of this destroy, because it is not taking the reference of pair. It is directly taking this pair. So it is moved. That's what we talked about. It moves the whole sort of ownership of that pair. So it is telling me let pair is equals to, move agar between pair and as right pair, which does not implement what? Implement the copy trait. Yeah, we know that. Why? Why doesn't it implement the copy trait? Because this is a pointer. Pointers, strings, vectors, and all that cannot copy because it takes a lot of time to copy bit by bit. It can clone, it can't copy. But cloning, is a procedural thing. So there is no implementation of copy for strings and all these pointers sort of things. We can clone them, we can move them, we can transfer their ownership by using move and all that. We can take the reference to them. That's what we can do. Now we are getting this that pair destroy, pair move due to this method call over 105, which means this moved this method call, and it says the value used here after move. So after moving it, we are using that value again. So this is not good. That's what it's telling us. It also sort of says that it takes self. If you are trying to use that pair or destroy again, if it is something else, we are taking self. So try making it sort of ampersand self if you don't want to give it the ownership. So it says destroy takes the ownership of the receiver self, which moves the pair. That's what it's telling me. Now these are some of the good compiler errors thrown at my face because we can understand what's happening because we are doing it. All right. So it's intentional, but sometimes if it happens unintentionally, so we can see these errors and we can sort of recall these errors that we have seen it somewhere. And even if we don't, we get a line number and sort of a hint at what's happening. If you want to do that like by your own will, then it's wrong. If you are just trying, it's good. You are all right. Just uncomment this or comment it out. Now closures. So closures in the fast track, I guess, in the fast track series, we have seen something like closures. So closures are function that can capture enclosing environment. Like for example, a closure that captures the x variable. So there is a value, and then we are saying value plus x. What it does, I don't know. but it sort of captures the X variable. That's what it's telling me. So closures are functions that can capture the enclosing variable environment. For example, a closure that captures the X variable. So it is capturing X variable. So the syntax and capabilities of closure make them very convenient for on-the-fly usage, which means you don't have to prepare for anything. You can just use them on the fly. Calling a closure is exactly like calling a function. However, both input and return types can be inferred, and the input variable names must be specified. So only characteristics of closure includes using pipes instead of parentheses. Yeah, it's called parentheses, no? We call it circular bracket or something like that. But it's parentheses and input variables. So instead of parentheses and input variables, we use pipe. Now optional, which is optional body delimitation, is that we can use squiggly brackets. A single line expression, which is mandatory otherwise in function, we can use just squiggly brackets if we need them. Otherwise, it's mandatory or not, I don't know. Now, the ability to capture the outer environment variables. That's why we use closures because of the ability to capture the outer environment variables. So we have a very simple code. We have a main. Inside that we have a let outer variable is 42. Inside that we are using a closure annotated. So we are saying that I is of type I32, which has a return value of I32. What we want is I plus outer value, and that's it. Over here, we are saying closure inferred, and we are passing just the I. We are not saying if it is of value of anything, and we are using the same I plus outer variable. I think they both will do the same damn thing. Now we are saying closure annotated then 1, closure inferred then 1, and we are saying let 1 is equals to again closure. We are not defining even anything inside those pipes, and I'm saying 1. Now we are saying it to closure returning 1, print the 1, which means this closure. So I don't know what it does, but it is interesting. So let's run it. Let's see. So first print call says closure annotated and 1. So we are printing 43, which is 42 plus 1, which is 43. Again, the closure input is also 43, same thing, because it's taking I plus outer value. Outer variable, not outer value, it's outer variable. So outer variable is 42. And this one is just printing the one. So I can't wrap my head around it for now, but it is very similar to using functions, but not exactly a function. And it doesn't matter if infer its type or tell it directly that what its type is or not. You don't even have to use these I32, like what will it return or not. And I want to see if we just don't, pass any sort of values, what will happen? Will we get a void type or nothing? Expected expression. So expected expression while passing the body of this closure. So it's telling me add a squiggly bracket only of one side. Start running it. What it's telling me is this delimiter might not be properly closed. So it's telling me that I should close it. I don't know what I'm doing, but let's do it. Now what? Help. Add over here. So I had another semicolon. So it was taking these semicolons as a statement. So that's what I'm, and it's telling me to remove semicolon from here. We'll remove semicolon from here. Over here it says remove from here, add over here. Any other thing? Require cannot be formatted. So I think now we are getting a unit type, so it can't be formatted. So we use, oh, we can't print question mark, no. So we'll just copy that question mark from here. Print this question mark. Yeah, right. Let's do it. Yeah, I see a void type, which is mostly if you write just an empty function and you try to take its value and sort of try to print it, you exactly get the same thing. So now these double pipes and squiggly brackets means that I am just writing or inferring or sort of using an empty function only and assigning it to a variable called one, and we are trying to that print that one. Good example, I guess. Shall we read all these comments? So first read it. So regular function can't refer to variable in enclosing environment. So like if there is a function which is taking I32 and giving back the result of type I32, then inside it function we are saying I plus outer variable, and it is saying to do uncomment the line above to see the compiler error. Compiler suggests that we define the closure instead. Why can't we use this? I don't know what is wrong with this, but let's see. It says this something like can't capture dynamic environment in a function item. And it says closure form, use closure form instead. So you can't use this outer variable over here. Why can't you? Because it is inside a function, so you sort of have to pass outer variable over here. So if you alongside with I, uh, you know, sort of send out, oh, we are also not calling this, no. So if we would have said something like, we also have something like n, which will have type again I32, and it will contain outer variable, then we can do this. Instead of n, we'll use outer variable over here. But yeah, you get the point. So I guess let's take a break from closure because we have to sort of wrap up mind around it. So I'll just leave this alone and we'll pause our audio for some times. Hello, so we are back. So what I think is actually this closure is sort of, lambda function that we use in Python, where we want the facility of using a function, but not actually using that function. So it's like not defining function, but we can use all the facilities that a function should provide, like a return value or returns, doing something with all other values and all that. It's like making a function, but not making a function. So it's like using a function, but not making a function. I know it's confusing, but we have a something called lambda function is in Python. So I can sort of take a reference to that in sort of closure. There's a lambda function. We can just use those lambda functions described in a single line, and it can be used properly. So that's sort of vibe I'm getting from this closure. So sorry, this is closures. Yeah. So let's read it from here. So to do is uncomment this line above. We tried it, gave us an error. It told us to use a closure instead. So the compiler says that we define a closure instead. Yeah. Now what? Closures are anonymous, and here we are binding them to a reference. So annotation is identical to function annotation, but it's optional. So as are these curly brackets. So wrapping the body, the nameless functions are assigned to appropriately named variables. Good. Closures are anonymous, and here we are binding them to a reference. So we are binding them to a reference. Annotation is identical to function annotation, but it is optional. So you can just use it like defining a function, but it is optional. Even if you don't, it won't give us an error. So sort of this is good. We are just sort of trying to create a small function like a function, but not actually a function. So it's a closure. Like lambda function is Python in Python. So annotation is identical to function annotation, but it is optional, as are the curly brackets. So these are also optional. Now the nameless functions are assigned to appropriately named variables. So the nameless functions are assigned appropriately to the named variables. So if there is a named variable, the nameless functions are assigned. Now call the closures. We say closure and annotated, and we pass one. So we're passing I. So we then, get I, which is added to outer variable, and we get sort of that return value back, and we print that. So easy enough. Even if we don't use all the shenanigans of the function, we still get the same thing. We can change its value to sort of 2, and it'll work fine, it'll run, everything is fine. All right. Now we should get 42 to 43 and 44. That's what we are getting. And instead of, doing all these long things, we just made it in one. And instead of defining or capturing anything, we are directly passing one, which we could, directly pass one also, but we are passing it in sort of a closure format. We could also use without closures, and it will not sort of give us any error. It did. It said expected function found an integer. Why did it expect a function? Because of these. Yeah. So it sort of expects a function. Oh, shit. Let me do it. And now it will give us a one properly. But if we wanted, sort of a function sort of way, so we say one is a function, and we are getting a closure which looks like a function, which acts like a function, but not a full-fledged function, or not a very rigid with all these function shenanigans, like saying the result type is this, use a curly brackets and all that. And we can use it like a function, like we can pass on a I, and we can use that I over here. Oh, sorry. Instead of passing I, we should directly pass some number. Let's say 5, and we want to get 6. So we'll say I plus 1, and it will give us I plus 1. That's good. Yeah, 6. So it's like using a function, but not exactly. So it's a closure. Good. Let's move on. So now capturing. What is capturing? I think it is a subtopic of closure. So let's see the index. Where is the index? Yeah. Yeah, so closures have subtopics like capturing as input parameters, type anonymity, input functions, and output parameters. An example in standard O. So there are more subtypes, which is iterator to any and searching through iterators. So I think we won't be able to finish it in time, but we'll try. We'll try. All right. So let's move on quick because we are now on subtopic of closure, which is capturing. So closures are inherently flexible and will do what the functionality requires to make the closure work without annotations. So this allows capturing to flexibly adapt to the use case and sometimes moving and sometimes borrowing. So closure can capture variables like by reference. We can say we can send something like ampersand t, which is by reference. We can send mutable reference by ampersand mute t. We can just send the value in a closure. It's good. So they preferentially capture variables by reference and only go lower when required. So we have a long main function, and then we have another one which is sort of short, but all right. Let's sort of understand. So we are first of all sort of using standard memory. So we are defining or sort of calling this memory from standard library in this whole code or function. Then we say something like let color is equals to string from green. So we are storing green inside variable called color. Then there are comments. So a closure to print color, which immediately borrows like ampersand of color and stores the borrow. All right. We store that borrow and closure in the print variable. It stores the borrow and closure both in a print variable. Oh, all right. So there is a print variable. So instead of printing that color, which was here, which was green, so like color green, it will store it because we've defined that print as not just print, we have defined it as a closure. So whatever this print ln value will give, our print variable will store that as a closure. Interesting. I don't know what we'll do with it, but let's see. So it will remain the borrowed, it will remain borrowed until print is used the last time. So until we, use the print for the last time, the whole color green will remain borrowed, which is not a very good sign because if we want to mutate this green from sort of red, we won't be able to use it until and unless this print drops its value because you can't use a mutable reference and immutable reference at the same time. We remember that, all right? So since we are not dropping this print anywhere soon, so just we can't say over here let mutable color be something like red. So we can't do that. So now what is it? Another comment says print ln only requires argument by immutable reference. So it doesn't impose anything more restrictive. What does that mean? Print ln, which is this, requires argument by immutable reference. All right. So it requires immutable reference or argument by immutable reference. So it doesn't impose any more restrictions. All right. So we are storing that in print and call the closure using the borrow. So we are not calling the closure, which is print, using the borrow. I don't know what that means also. But now we have a color can be borrowed immutably again. So we have a color and we are reborrowing it. Yeah, we know we can borrow as much as immutable types, as many times we can take immutable reference multiple times, hundreds and thousands of times because they are only reading the data. But as soon as we try doing something with immutable and mutable at the same time, so simultaneously, it will go bonkers. It will throw us errors. So color can be borrowed immutably again. We know that because the closure only holds an immutable reference to the color. We know that. So we are again trying to print color. to sort of verify whether it works, it is there or not. Then we have again another variable which is unused. Therefore, we have used the underscore before defining that variable's name. Now this variable is called color moved, and now we are moving that color over here. So instead of having a color over here, its pointer now gets moved to some other variable called color moved over here. Now I guess we can't use print. So a move or a reborrow is allowed after the final use of print. So this was the final use of print, and after that we can do whatever we want to. Like we can immutate this color, we can not only use it by reference, we can move this reference, we can change the owners, do whatever we want, but only after the final use of print. Like if we try to print it over here, it will throw us some invalid errors because color has now moved to another variable called color moved. So now there's another thing which is count. So we have a mutable count variable, which is first of all initialized with 0. So a closure to increment count could take either mutable count or just the count, because it is mutable, so and it is a number, so you can copy it. But mutable count is less restrictive, so let's take that. So yeah, let's take the reference of mutable count because we can use it. We can do anything with it. We know it is safe. And immediately borrows count. So I don't know where are we doing this. So we are taking the reference of mutable count so that we can increment, and then we are saying that immediately we are borrowing that count, which means we are taking the reference to that count. Can we do that at the same time? No, we can't take a mutable reference and do anything again with it without closing that mutable reference. So mute is required for on inc. So this is a variable inc. Now it is also mutable, and we are passing a reference of mutable again, which is of I guess count, because ampersand mute is stored inside. Yeah, we have ampersand mute stored inside, which is count is equals to +1 or plus equals to 1. We are incrementing it by 1. That's calling the closure mutates, and count which requires a mute. So instead of taking that mute count and doing the reference, we are just directly taking or borrowing the count, and it works because it is inside a closure. It's like a function, but not a function exactly. So we can do that, I guess. Now what are we doing? We are calling the closure using a mutable borrow. So now we are directly calling a inc, which is inc, and we can do that. We can do that, but it is sort of a mutable borrow because inc is mutable in itself. So closure still mutably borrows the count, but it is called later. An attempt to reborrow will lead to an error. So if I say that reborrow and we are reborrowing that count, will lead to an error. We know that. We know that. That's what I was telling for, I don't know, 7 minutes. We'll try that. And then what we are calling this inc again. It works, and we have a again different variable which is count reborrowed, and we are again taking a mutable reference to it, which I guess we can if we close this inc, but if we don't, we can't. If we try to call inc over here again, it will throw an error. This can't happen. So the closure no longer needs the borrow ampersand mute constant. Therefore, it is possible to reborrow without an error. So it's telling me that it is the last inc. So it is not taking the ampersand mute count again, this inc variable. So now we can reborrow it. That's what we can do. If we sort of close this inc anytime soon, we can do this. Or if we close this inc from here, then we can also use this. So it works only if we close this first. All right. Now there is a non-copy type. So we have a movable variable which has a box of new, which is pointer to new 3. All right. Now what it does is memory drop requires t. So this must take by value. Copy type would copy into closure, leaving the original untouched. The non-copy must move, so movable immediately moves to the closure. I don't know what that means right now, but let's see. So there is a closure inside in a consume variable. In that closure, we have a print statement which is trying to print movable, and then we say memory drop movable. Can we do that? Can we do that? So what it expects it to do? Consume consumes the variable, so this can be only called once. We can't do it twice. All right. So we have a movable pointer, sort of, and we are trying to print it and store it in a closure. And after that, after printing, we are saying memory drop the movable. So we are not not borrowing or not even taking the reference, not even taking the self. We are using the memory, standard memory, to just drop this movable variable. So that's what it's doing. So it's telling me after defining this consume, we can only use that consume once. We can't do that twice because memory has already dropped the variable called movable. So let's see. Uh, color is green, count is 1, count is now 2, and movable is 3. So movable over here has 3, and memory is being dropped after 3 over here. So we can try uncommenting this and use this memory again. Let's see what sort of error we get. So we are getting that consume moved due to this call and value used here after move. So memory dropped movable and you can't use consume again. So fn once, which causes it to move when called. So it's not only hinting us, it's probably telling us everything that we need to know. So I think non-copy type, I guess we know what it means. So let's erase it. And now let's try using these without any comments so that we can see all the code. Remove all these big comments. Oh shit. Inside that comment, we also have a reborrow that we want to take. So we'll do this. It's still not shortened. So let's shorten it further. I want to see, oh shit. I guess now this code is quite shortened and we can see the result as well as everything that we want to at the same time. So let's try doing it. First of all, it will throw us an error. Why? Because we are sort of using the variable ink after we are trying to reborrow it using ampersand count, which is just immutable borrow. But we'll get an error. But I don't want to see error at the first time, so let's just do it without any errors. We get error because oh shit, we have not closed it, or we have sort of erased it out of the existence. Hmm. So everything looks fine. We have a color green. We are getting that from print. We have again a color green. We are getting that again from print. And then we have a count 1. We are getting that from count over here. And we are incrementing it again because of the ink call. So we have a count 2. If we try to do it again, we'll get a count 3. So and home copy and sort of paste, 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 paste. Yeah, so it works. That's probably what it's doing. So we have a variable which now works like a function, but it is a mutable one. So everything is fine. Oh, just print it once. Now this is what I have to do. So now what? What we are trying to do right now is, first of all, we are seeing that we have reborrowed the count, which was this. Where is this count? Let's sort it out. We have reborrowed this count from here to again here, and it doesn't throw us a error at all because we don't use ink, you know, below that. But if we try to, we'll get a definitely a error. Let's see what sort of error we get. Yeah, so it says that first mutable and all that, but the more says we get a 25 ink. It says second mutable borrow occurs here. So it's talk about, first of all, first mutable reference that occurred in mutable ink and all that. Now it tells me that there is a second mutable borrow occurring over here. So we can't use the first borrow later, which we did. So we can't do that. But if as soon as we remove this first borrow, so there is no reference to that we have a first borrow and anything like that. We have dropped it. Now what we get is a normal function. All right, so we get this point. We get this point. So let's remove it. Now what? Now we are not taking a mutable reference, but let's say we are taking a immutable reference. Like we are not changing anything, but still we can't do this. That's what we have been taught. We can't do this. Why? Well, because if something is writing it like the count is becoming from 1 to 2, what will we read first? Will we read 1 or will we read 2? Why? Why will we read 1 if it is going to change right next after it? And if what it was expecting the next time was also 1 and we instead gave it 2, it would have been quite unpleasant. So it is sort of, data race. That's what you call data race or something like that. And it's not good. It's not good for us. So it says something like mutable borrow occurs here, and we are taking trying to take a immutable borrow over here. So it says it doesn't work like that because mutable borrow is later used here. So you can't just use a mutable variable or mutable borrow after sort of trying to borrow it immutably the next time. Either remove this or remove that. So we'll remove both of them because we now understand what it means, right? So let's move on. We have a count and everything works fine. If we make it in a single line, because that way it will be more clear to me. So yeah, it looks like a function, but it is a very shortened function. So like a lambda function or something like that. So we are taking a count inside and we are trying to increment it by 1, then we are trying to print that count, and after sort of printing it, we want that count over here inside a closure. So we will give ink that value of that closure. As soon as we sort of try to call this ink like a function or a closure, we get what we wanted to, which is count is equals to now 1. If we don't want to increment it at all, we'll leave it as 0, or we can even remove it, but I want to increment it by 2 or 3, so will not. So count remains 0. If you want to increment by 3, we can do that. We'll get a 3. Yeah. So we can exactly use it like a function and it works. It is good. That's a closure for you. And closure is now closing, so let's close it. Now this color thing. So we are using sort of reborrowing it, color, and since this whole damn color and print were both immutable, we can do that because we are not changing anything. So we can take a reference to immutable variable multiple times. if we are not trying to change anything, because immutable we can't change. Immutable, in sort of mutable variable we can change, we can mutate anything, but in a immutable we can't change. So there is no sort of error that you can't take a reference to your immutable variable again and again and again. We can do that as much as like I want. All right. But as soon as we moved this color, now I can't use this print back again. So if I try to call print over here, print over here, well, it should throw us an error, a very dramatic one. Yeah. So it says that this first borrow occurs here, something like that. Borrow occurs due to closure, and borrow of color occurs here. Then we we have moved the value of color over here, and borrow is later used here. That we can't do. So either don't sort of move the color, or just don't borrow it afterwards using a print. That's what it's telling us. And we know that, so we'll remove both of them because we now know. But again, this immutable reference, as for just reading it, we are not moving it, we are not changing anything, we are not doing any sort of thing. We can do this as much as I want, like as many times as I want. There's no error for this. All right, we are getting absolutely fine. We can use print after this also, so we can use print anywhere right now because there's no change occurring. Everything is just reading that data, and there's no problem just reading that data. So yeah, print is now 3. You're getting 3 times. As for the formatting, well, this is because of these sort of editors are not very great, but it's doing a thing. So we have a color string from green, and then we were trying to store that closure in a variable called print. That's what we were trying to do. Huh. Now this looks fine because that's how we take a closure, take the reference of color and store that in a color green in sort of a format. What if I said, something like format ln? Well, nothing dramatic should happen because format ln doesn't print anything. So format ln, but we have not imported format, so I should get an error. Yeah, yeah. Format defined here. So, and memory is unused, so we shouldn't be using it. Let's go to remove. Let's remove this. Not F12. Sorry. Format ln. All right. If we just use, because about macro we know nothing, like near nothing. We just know there exists something like format, there exists something like print ln, write and all that. So there exists a format. All right, we have used that format. It doesn't do anything dramatic, so you're sort of printing it. But what if now that I want to print this print? Now this seems funny, but believe me, it is not. It is confusing as hell, but I want to see what format does to our whatever. Print ln, print. So it's yeah, sorry. I forgot the basic aggregates for printing something. That's my mistake. So we now get a color green that we have already got after doing this much, which is format, because format doesn't print, it just formats. So we format something like color in sort of a syntax where we are calling it like we have a color and then we are using a semicolon and we define that color. This is a green color, something like that. And we are formatting that, we are storing that in a closure, which is stored in a variable called print. And then we are calling that closure and we are trying to print that closure. That's what's happening right here. What if I say something like write? Write is also a macro, and we have used it in implementation for displays. So let's try writing a write, write, write. Write is a macro. We've used it. What it does, we don't know. So it says something like color is there, color, which color do you want? You might be missing a literal, all right. Cannot write into ampersand static method not found. So write is for format. FMT, I see something like FMT, write. FMT is also used for display. So we only write for our displays. So write function or write macro is not for our sort of purposes without any display. So if we only write print, we don't get any sort of, backslash n, and it says cannot be default. All right. So I want to know what this print. Ah, I can't, use question mark without getting this prompt. So I have to copy it and paste it. I want to see what print returns. This print returns this whole damn thing. That's what it does. We've known that for quite a lot of time, but not a very long time. So we don't get any new line. But if we try to print ln, so we should get two new lines because print ln already gives us a new line, and we are trying to print ln that print ln. So yeah, yeah. We also get a void type. I don't know why. Print ln also returns something, or is it because why is this? Is it because of this? Let's first of all call the print print. We are calling a print, and everything should work fine. But yeah, so print is calling the color green, whereas what we are trying to print that print because of println, we get a void type. So println returns a void type. Now that's a new for me. Now that's definitely new thing for me. But print doesn't. So if we just use that print macro, it doesn't return a void, I guess. Oh, it returns, but without a backspace. Shit. Without a new line, it returns a void type. Damn it. So both print and print ln both returns a void type. The difference is just about who gives you a new line to print that unit type, not void type. If I am calling it void type, I am sorry. I am sorry. I am literally sorry. Yes, now we have already played with this playground multiple times. Let's move to this move where we have a function. So using move before vertical pipes forces the closure to take ownership of captured value. So it doesn't just captures the value, it takes now the ownership. So there is a main function. Inside that we have a vector that has a non-copy semantics, and that vector is stored in a variable called haystack. Inside that vector is also sort of a macro because we are getting exclamation mark. We are storing 1, 2, 3, and then we are using a closure, but we are moving something like needle, and needle is something inside haystack dot contains needle. So whatever the haystack contains, which is sort of a needle, we are referring it to needle, and we are using needle over here, and we move it. What happens? I don't know. Then we are trying to print the contain and ampersand 1, and we are trying to print contain ampersand 4. Let's first of all see what is the output, because this is new for us. So we are first of all getting true, second we are getting false. Why is that? So we now know that there is no such thing as haystack. So if we try to print a haystack, well, we should definitely get a error. How to print a haystack? PRINTLN. How to print a haystack? Let's try printing a haystack. It is a vector, so I don't know how to print it, but let's see. So it says vector integer cannot be formatted. So we require something like Ah, shit. But I copied it, so. Hmm. So it says we have moved haystack. So before, just try to print haystack before moving it anywhere else, so that we see there is a haystack. Oh, so now there is a semicolon error. Why weren't we getting it earlier? Because we were just using it as a last sort of statement. Yeah. So we see that we used haystack properly, so we can print haystack. But as soon as we try to do it afterwards also over here, we can't. Why we can't? Because we have now moved the haystack to something called contains. So now we can't print haystack. And this will be our error that we wanted. So it says borrow of moved value haystack. So we are trying to borrow something that is already a moved value, which is haystack. So move occurred here because haystack has a type vector i32, which doesn't what? Which doesn't has a copy trait. We know that. Now what it does is let contain move needle haystack contain needle. So various variable moved due to use in a closure. So because of use in a closure, it moved. Because it says move. Now value moved into a closure over here. So as soon as like I want to remove this move, so will that just take it by reference or will it also move it? So it took it by reference and it didn't move it. So that's good. That's good. If we want to sort of move the ownership of haystack from haystack to contain, we can do that using a move. That's what it's telling us over here. That move before vertical pipes forces user to take ownership of the captured variable. And if we don't use a move instead, we don't get to own the ownership of the haystack. So it's like normal. So move is a new keyword that we want to use. But I didn't get the point of, ampersand 1 and ampersand 4. So what was this? What was this? So ampersand 1, ampersand 4. If we just try to print it without any ampersands like this and question mark, check. I can't print question mark, so I have to, copy this question mark first, copy it, and now try to paste it. I want to see what is happening. It timed out because there was probably some error. Probably not. If it times out again, well, I want to see what it does. So let's just copy this whole damn thing and let's move it to our environment. Let's call it. Let's call it what? Pipe.rs. Paste it and try compiling it using Rust C. So Rust RUSTC Rust C. Then pipe.rs. It compiles, so there's no error. So yeah, it definitely doesn't show us anything that we wanted to see. Like why is it giving us true or false? Like it should be 1, 2, 3. Why are we getting ampersand 1 is getting what? Ampersand 1 is getting like what? What is ampersand 1? Because we don't know what vector is, so it probably because of that. But let's say we don't have any ampersand, we don't have any for. Now what is it? Will it combine first of all? No, it doesn't. So argument 1 has a type of ampersand integer which is missing. So move needles. So we should contain something like provide an argument for needles. All right. So now So doing all that, what is this needle? Just try printing it with this haystack and needles and all that. Will it print it? Because we don't know what's happening, and we have spent quite a lot of time. So I guess we should move on because needle is not defined over here. So what if we don't define anything? Then it will probably define something because it's ampersand integer because of the vector. Hmm. Says the same damn thing, which is ampersand. So we don't know about vectors. That's why I guess we are not able to play with it enough. But let's move on. Move on how? Move on by saying that println is their element in vectors, which is haystack.length. Oh, so there is a way haystack.length because it's a vector, so we get a length for the vector. Then try uncommenting this line will result in a compile time error. Well, it should because there is no haystack now. There's a contain. We can use contain. Can we use contain over here? Contain. Contain. Contains, sorry. But contains has some needles and all that, so it is a different thing. Method not found length. So contain doesn't have a method called length. Well, that was expected, sort of. So now because borrow checker doesn't allow reusing variable after it has been moved. So now removing the move from closure signature will closure cause closure to borrow haystack variable immutably. Hence haystack is still able available and uncommenting above line will not cause an error. So it says if we try doing it like this, but now instead of using that move, we have used it. If we remove that move and try printing that haystack, it works. But now we are printing the haystack.length, we'll get that. So there are three elements in the vectors. So haystack.length is 3. Let's move on, I guess. And there is a box and C memory, standard memory drop. So how does the drop works? That what is telling us to follow. Now we are in as input parameters, like over here only. Well, we should speed up, I guess. But it's a lot of theory in function, which is important also, yes. Yeah. As input parameters. So while the Rust chooses how to capture variable on fly, mostly without type annotation, this is ambiguity. So while Rust chooses how to capture variable on the fly without type annotation, this is just ambiguity and is not allowed when writing functions. When taking a closure as input parameters, the closure's complete type must be annotated using one of a few traits, like they are determined by what the closure does with captured value. So in order of decreasing restrictions, there are function like fn, and closure uses the captured value of reference by reference. If there is a function mute like this ampersand mute t, the closure uses the captured value by a mutable reference. If there is fn once, the closure uses the captured value by directly t, which means it is moving it. So it moves that value, and that value never exists. So it sort of ceases to exist after it is used in fn once. Now, on a variable by variable basis, the compiler will capture variables in least restrictive manner possible. For instance, consider a parameter annotated as fn once. Now, this specifies that closure may capture by ampersand t, ampersand mute, or ampersand or t. Like closure may capture it like that, but compiler will ultimately choose based on how the capture variable are used in closure. So like t only. Now, this is because if a move is possible, then any type of borrow should also be possible. Note that reverse is not true. So, if parameter is annotated as fn, then capturing type by mutable reference mutable of t or just t or moving the t are not allowed. However, just taking the reference of t is allowed because that's what the fn does. You know, fn does just the reference of t, whereas fn mute takes a mutable reference of t. Fn once just moves the damn t. All right. So however ampersand t is allowed. So in the following example, try swapping the usage of fn mute, and fn once to see what happens. All right. So there are some main function is good. There are two other functions like fn apply, and inside that there's fn once. Then there's apply to 3. Inside that we have just fn. Yeah, it's good. So let's start from the top comment. It says a function which takes a closure as an argument and calls it. So this, f in angular bracket, f denotes that f is a generic type parameter. Like, this angular bracket t. We've used it. We've used it to create our own calculator or something like that. Calculation or compute engine. Yeah, compute engine. We've used generic t in there's a dynamic type, then there is a static. Yeah. So in a static type, we have used generic t. Static dispatch, we have used generic t. Over here, we are using that angular f, which denotes that f is a generic type parameter. We know that because if it is angular t, we know that t is a generic type parameter. Let's move on. So in a function apply, which has a f, which is generic type parameter f, and the input of this function apply is f, which is of type generic f, generic type parameter f, where the closure takes no input and returns nothing. So where the f, which is generic type, has a sort of a function fn once. Now this means that f has a type of fn once. It doesn't assign it to f. What does with this? And so we are defining f as fn once, and then we are trying to sort of call the small f, which is a generic type f. Now this is confusing. That's what I call confusing function, because we clearly don't know what it does, but we are trying to learn it. So it says try changing this fn to fn mute. Well, this is not a function, this is a fn once, so it moves whatever it gets. So let's see, where is it? All right, I don't see anything related to this. Let's move on. A function which takes a closure and returns a i32. So there is a apply to 3 function which takes a f and returns a type f32. Where? Why are we using where instead of just opening and closing a curly brackets and doing something inside a function? That's what we typically do with a function. But over here we are seeing where, and then we are saying where f is fn ones. Over here we are saying f is fn i32, which is of type i32. No, which returns a type i32, and then we are defining a function which is like f of 3. So it returns a 3. Now this is funny as well as complex. So the closure, where is the closure? I guess this is the closure. So like, what is the use of closure if we have to define it like a function? So I thought the closure was used like a lambda function in like in Python, so that we don't have to define a function. But over here, the closure seems something very different. So the closure takes an I32 and returns an I32. All right, all right, we are good to go. In a main, we'll be using apply, which is fn once for now. We'll use apply to 3, which is fn for now. So let's see what this fn main does. So we are using again standard memory, and we are saying let greeting is equals to hello. Now this is a static hello, so it will live for a lifetime of this program if it runs. Then we have a mutable farewell which says goodbye, and then we have a flag or a method which is to owned, which is I guess to owned by farewell, mutable variable. Let's read the comment also. So a non-copy type that is to owned creates owned data from borrow one. So a non-copy type to owned creates owned data from borrow one, but it didn't borrow it for now. Well, it did. So, but if it did, what it'll do is it'll own that borrowed data. So if it does any sort of borrowing, it will just own it. So a non-copy type, which is to own, creates a own data from the borrowed one. So creates a own data, a new sort of own data from the borrowed one. So let's see. Now over here it says capture two variables, which is greeting by reference and it is farewell by value. So there's a diary, which is a closure. Inside that we are saying greetings is by reference requires fn. We are saying I said greeting, which is I said hello, and it will print it and store that in diary closure. So we have to call the diary, but we are calling it using apply. I don't know what's happening right now. Let's move on. Then it says that mutation force, which is farewell to be captured. All right, so farewell is to be captured. And then we see something like mutable reference now requires a fn mute. And farewell push string is now pushing something like exclamation marks. So farewell was goodbye. We are pushing string that is exclamation marks. So it will be goodbye with 3 exclamation marks. And then we are saying then I screamed farewell with very enthusiasm because it has 3 exclamation marks. And then now I can sleep. We are printing that. And after that, we are saying that manually dropping the farewell. We manually calling the drop forces the farewell to be captured by value and now requires fn once. So we are doing it. We are dropping the farewell. I am not understanding quite well right now because fn once, fn, all that. Instead of just seeing it very simple example, I'm seeing very complex one, which has two own. I don't know what this does. Uh, it is saying, I know push string because I've used it is to say something like hello and to mutate it to something like hello world. So I've used to push or the push string. I know this, but we are capturing farewell. We are dropping farewell. What are we doing farewell? And then we have apply diary. So instead of just saying that we have a closure of diary, we are now saying apply diary. Now what this does, I don't have any idea. So apply is also a function. So yeah, inside that we are passing our closure that is diary, and what it does is, well, what it does, I don't know. It calls the f. So apply diary will take the diary for once and will just call the diary. After that, I guess the diary will be forgotten. So if we try to do it again, it will not be able to print it. That's my assumption. All right, calls a function which applies the closure. So we are calling a function like apply, which sort of applies the closure, and then it disappears because it is fn once. Then we have a double, which is again a closure. So x is, we are passing x in a closure, we are multiplying it by 2, and then we are storing that over here. So if x is, what is x? Apply to 3, and we are passing that double. So what is the value of x? Where are we passing this x? Where is this value of x? Where is it? I don't see a value. Oh, oh, oh. So let double, then inside that we have a closure x, we are multiplying that x by 2. Then we are saying println whatever it is. Then we are saying 3 doubled and this, and we are passing that to apply to 3, and we are passing the double. So pass the double is going over there. Double becomes the f buffer, which is a generic type, which will give us a i32. Now what it is doing is f is of type fn, which takes it by reference. It doesn't move it. We can use it afterwards, and it has a i32 value, just it takes also i32. So now f also has to take a 3 value, and it has this x value from here, which is 3. It does operation with 3, like multiplies it by 2 and then stores it back to a closure that is double, and then it sort of returns this value because that's what is said getting returned, because there is no semicolon. So this is the i32 that we return after, you know, using all these doubles, closure, multiplying it by 2. Now we just directly print it, which is 6. This is crazy. But before moving on, we'll try printing this again, which should throw us an error. That's what we are expecting. So let's see expectation versus reality. It does. Thank you. So it says value has moved here. So apply has used this value. So because of this fn once, it has been used, and then the ownership has been transferred. Afterward, it is dropped. But important is, if we just change this fn once to sort of fn, just fn, so that it takes it by reference, not a mutable reference, just a reference. Now we can do this. We can, shit. So it drops the farewell. So the next time we call this diary, we can't call this farewell. So let's just comment it out for now. Now let's call this diary again. Now it is just warning me first, and then it says that this closure implements fn mute. Well, it doesn't. Well, where is it? Where is it explaining that it only use fn mute? Because we are trying to mutate it. So it says implement fn mute, because in diary we are mutating something called farewell, and we are also taking that farewell. So to take farewell, we have to either mutate this diary or we have to use fn mute. So let's do both. First of all, let's say mut, then we'll remove this and we'll try this again by mutating, making this mutable. Now this says anything, f borrows as a mutable, cannot borrow as a mutable. What the hell is going on right now? This is now causing some issues, like, all right, I don't know, I don't know. It was immutable, so I made it immutable. Then it caused errors. So instead of pushing a string, instead of changing anything, let's call it, yeah, it works. So if we don't make a change from closures diary, everything works. But if we try to make a change, we get multiple errors. Now we are getting two times applied ID, but let's now make a change where we can see what's actually happening. As soon as we are making change, closure is fn mute because it mutates the variable. All right. Requirements to implement fn derives from here, which is applied ID and all that required by a bound introduced by this cell. Bound is fn over here, but it says that to mutate anything, you need fn mute as a closure. It says this closure implements fn mute, not fn, because of this, farewell push string, and that's what it says. So what should we do? It also says required bound, so required by this bound in apply. So I think we should for now just move on because you're not getting anything from this. Instead, I want to try this last time, like just mutate this whole damn diary. Now it has a long list of and instead of just taking fn, we should say it is fn mute. Oh. Over here it says you have to use mute so that it takes it by the reference mute. Now what it says? Help remove this mute. All right, so this is also causing some errors. So let's just remove it. Now what it says? Value used here after move. So we shouldn't use it. Yeah, mutable shouldn't be used two times. So let's remove this. Now just do what I'm telling you to. Ah, it did. It did. Shit. Oh my God. So it works, I think. And I think I got the point, but I really don't know the point for this. But let's move on. So it has used memory drop, it has used fn, has used fn mute, it has used generics, where and fn once. Where, defining over here, where we have never used where anywhere else. Now type any anonymity. So anonymous setup. Then we have an input function as output parameters, example in standard, and there are multiple examples. Aha, we are not near even closing it. We are not even near closing this. But let's try to. There's f must be generic, so f is generic. fn once. We are applying it, and then we have a one. We are taking x is 7. We are saying print and print ln x. It captures x. It goes to apply print. We are applying print over here. We say it works, everything works because we have seen this code, but we don't know the theory, so we have to read all this. Oh, just run it now. What does it print? It's print sevens. If it is x plus 1, it will do that operation because closure is there. So closure does what you tell it to do. Plus 5, 7 plus 5 is 12. So we get a 12. Good. So let's read this theory. So the theory states that closure succinctly captures the variable from enclosing scopes, and does it have any consequences? So closure succinctly capture variable from enclosing scope. Does it have any consequences? I don't know. We don't know. You only used closure once or twice, just these three times. It surely does. Now observe how using a closure as a function parameter requires a generics. So which is necessary because of how they are defined. So f must be generic over here. That's what we are defining, that f is a type generic. and f is a buffer which has a type, small f is a buffer which takes the type of f generic, where f is fn once, and we are just, calling the f buffer, which is, for over here it is just a print. All right, so we are calling the print. Instead of doing all these apply and all that, we can just do this simply. We can say print and call it using this, and it should work just fine. But I don't know why we need to, apply print, because we are learning something called apply, which takes a generic trait f. F is a small f is a buffer which is of type generic f, where the generic f is of type fn, not fn mute, not fn once. All right, and then it calls the function which is print. So because it is f, I guess we can call it multiple times. So we can say something like this, and it will work. But as soon as we say fn once, we move the fn. So we don't get to call it multiple times. So as soon as we do this, it moves it transfers its ownership, and done. In just one go, it will throw us an error. Shit. So I guess we have to say mute or something like that to make this work. But over here it doesn't. So I don't know what happens. I don't know how all this works. Let's make this mutable. How about that? Like earlier it was throwing so much error, now it's not even throwing a mud. Damn. Damn it. I think it is because of this, I guess. Let's make it mutable X. Shit. I am now, the last guess is that because X is of type, numbers, it is getting copied. So I don't know what's happening over here. So let's just see the real code and let's move on. So observe how using a closure as a function parameters requires generics, which is necessary because of how they are defined. So we know that f is generic and it is required, and we have a fn ones and all that. When a closure is defined, the compiler implicitly creates a new anonymous structure to store the captured variable inside. Meanwhile, implementing the functionality via ones of the trait fn, now fn mute or fn ones for this unknown type. This type is assigned to the variable which is stored until calling. Since this new type is of unknown type, any usage in function will require generics. However, an unbounded type which is t would still be ambiguous and not be allowed. Thus, bounding by one of the traits, that is fn, fn mute, fn ones, which it implements, is sufficient to specify its type. All right, whatever. Let's read this theory again so that we don't forget it. When a closure is defined, the compiler implicitly creates a new anonymous structures to store the captured variable inside. Meanwhile, implementing a functionality via one of the trait, which is fn ones, fn mute, for this unknown type. Now this type is assigned to variable which is stored until calling. Now since this new type is of unknown type, the usage in a function will require generics. However, an unbound type parameter, which is t, would still be ambiguous and not be allowed. Thus, bounding by one of the traits like fn, fn mute, fn ones, which it implements, is sufficient to specify its type. Now, input function. Since closure may be used as an argument, you might wonder if the same can be said about the function. And indeed they can. So if you declare a function that takes a closure as a parameter, then any function that satisfies that trait bound of that closure can be passed as a parameter. So here we have a define, we have a call me function, we have a function, we have a main function. So define a function which takes a generic f argument bounded by fn and calls it. So call me is a function which takes a generic f which is of type fn, and it does call it. So it calls it. That's it. That is it. So over here we can directly say f is of type fn once, just like over here. Will that be any different? uh, Instead of we used sort of where and all that, so we used where, which is f is f and f once. So instead of using where and all that, we just directly said it is of type fn. All right, then we define a wrapper function satisfying the fn bound. So we have a function which is a function, like the name is function, and it prints that I am a function, simplest function. Now there is a main which says, like, it defines a closure satisfying the fn bound. It was also defining a sort of fn bound wrapper satisfying the fn bound. I don't know what it does, but now there is a closure which stores the value of I am a closure, and then we call the closure and then we call it on function. So we are using call me on closure and we are using call me on function. So what should it do? Well, it should just call that closure and function, which are of type fn, not fn mute, fn anything. If we just change it directly from here, something like fn mute, will we see some errors? Yeah. So it says f cannot borrow as mutable. So it says consider changing this to a mutable. So I have considered it and we'll change it. I'm getting it now. Wait a second, wait a second. I guess my stream sort of ended. It didn't. Wait a second. I'll just pause it. I'm stopping.